Good morning, this is Mr. Precella, and today we're going to continue our discussion of solving equations. The last time we looked at the addition principle and the multiplication principle. You can add or subtract any number you want from both sides of the equation, or you can multiply and divide both sides of an equation by any number you want, except for zero. If you multiply everything by zero, then you get rid of everything. So in this one, this assignment we'll be looking at both problems where you have to do both the addition principle and the multiplication principle. And our goal is to isolate the variable, so you have like x equals a number, okay, or whatever the variable is. To isolate the variable, perform the opposite operation to both sides of the equation, beginning with addition or subtraction. To demonstrate what the heck I'm talking about, I'm going to do a few examples here. And here's the first one I'm going to do. 6x minus 14 equals 40. Well, this is 6 times x, so the opposite of multiplying by 6 would be divide by 6. The opposite of subtracting 14 would be to add 14. So what do we do first? Are we going to divide both sides by 6 or add the 14? Well, you begin with addition and subtraction, so you're going to add 14 to both sides of the equation. And when you do that, on the left you just have the 6x. And look at what happens here with the 14. Negative 14 plus 14 is gone. Oh, and look at that. I put plus 4 when I mean plus 14. 40 plus 14 is 54. Now I need to get rid of this 6. I'll do that by dividing both sides by 6. The opposite of multiplying by 6 is dividing by 6. So now we have x equals 54 divided by 6 is 9. So 9 is our answer. And you all remember how you can check these if you want. Plug the 9 in for x. 6 times 9 would be 54 minus 14 equals 40. Yeah, 54 minus 14 is a 40, so I know that this answer is correct. Something, as we do more and more of these, right here, instead of adding 14, what you might see teachers or tutors do is just draw a little arrow like that. Okay? And that little arrow means add 14 to both sides. You're moving the 14 over and changing the sign. Okay? So if you don't want to write this plus 14 there, you're moving the 14 over. 40 plus 14 is 54. Let's do another problem. Negative 103 equals 5 plus 9x. Usually you see the x on the left-hand side of the equation, but there's certainly no reason why you can't have the x on the right. So don't let that worry you. The only difference is you'll have the x on the right equals a number on the left. Okay? So let's see. If I'm trying to get the x by itself, I would have to divide by 9 to get rid of this 9 right here. To get rid of the 5, what would I need to do to both sides? Add it or subtract it? Well, sure not add. If you added 5, that would just give you a 10 here. So subtract 5. Negative 103 minus 5. Negative 103 plus a negative 5 is a negative 108. Now the 5's are gone. 9 times x. And now, what would I do to get this x by itself? Well, how about, this is 9 times, so the opposite of multiplication is division, so divide both sides by 9. And we have x on the right equals negative 108 divided by 9. Well, that's going to be a negative number, right? When you divide a negative and a positive, you get a negative. And 108 divided by 9 is a 12. So, I think I mentioned having those multiplication tables memorized. If you don't have the 12s memorized, then punch in 108 divided by 9. Okay. Negative 12 is our answer there. Let's do another example. How about positive 14 minus x equals 5. This is one of those that I think if you were doing this in elementary school and it had just had a little like that, I bet you could get the answer. 14 minus what would give you a 5? I bet most people could figure that out. Well, it's got to be 9. 14 minus 9 is 5. Well, let's go about this algebraically. What I want to show is this minus, what's going to happen with this minus here. First of all, I can get rid of the 14 by doing what? Adding 14 or subtracting 14? Well, if I added 14, that would give me a 28. You have to subtract 14 from both sides. And when you do that, you have negative, the 14 minus 14, it's gone, negative x equals 5 minus 14. Is that a negative 9? You know that's not right, because when you just have a little box here, it should be just a 9. 14 minus 9 is 5. But remember that this negative right here in front of the x, that's actually a negative 1. So negative 1 times x, what am I going to do? Well, divide both sides by negative 1. The same way I divided both sides by 6 here, and over here, what did I divide by? 9. The coefficient is the number that's attached in front of the variable. The number that the variable is being multiplied by. Here, the variable is being multiplied by negative 1. Divide both sides by negative 1, and we're going to get x equals negative 1 divided by negative 9. There's your positive 9. That we knew had to be the answer. Let's see. Let's do a problem that has a decimal. Problem 4. 4.3 plus 1.6. That's sort of messy. 4.3 plus 1.6, and let's use a variable instead of x. So I guess n, use the letter n, equals a negative 0.18. So you might want a calculator on this one. All you need is one that can do this, multiplication, add, subtract, multiply, divide, decimals. Now this problem is going to go through the same steps we did on the other ones. What are we going to do first? Well, are we going to multiply by divide by 1.6, or are we going to get rid of this 4.3? Well, get rid of that 4.3. So I'm going to do what? Add 4.3 or subtract? Well, subtract it. So adding 4.3 to both sides of the equation. The 4.3 is gone, leaving us just a 1.6 n. And let's see, a negative 0.18 plus a negative 4.3. Think of this as negative plus negative. That's going to be a negative 4.48. So just punch that into your calculator. Or, okay, you're adding, just add vertically. 8, 4, 4. Carry down the decimal point. So we have 1.6n equals negative 4.48. To get the n by itself, now's when you divide both sides by 1.6. 1.6 divided by itself is just a 1. So we have n equals negative divided by positive is negative. So just punch into your calculator. 4.48 divided by 1.6. Now getting 2.8. So a negative 2.8. Usually in algebra we prefer fractions, but you'll see sometimes when there's decimal numbers. Okay. Let's do another one. Now in all of these problems, there's just one variable. So right now, in this next one, I'm going to try to show you what do you do if you have more than one variable. What do you do if you have more than one variable? Okay, and here's the next one I'm doing. $8x plus 13x equals 24. 18x plus 13x equals 24. How does this differ from the other ones? Notice in the other ones, you didn't have an x here. On the 14, you only had the variable appearing one time in the equation. Here it's twice, so what do? Well, you already know what to do. You're going to combine those like terms. 8x and 13x are like terms, so to combine them, it's like 8 apples plus 13 apples. There's 21 apples. So we have 21x equals 24. Now, can we get the x by itself? Well, you betcha. What are we going to have to do to get the x by itself? Are we going to, okay, I'll give you the choice. Are we going to subtract 21 or divide? Well, divide. The operation that's going on here is multiplication. So divide both sides by 21. And we get x equals, 24 over 21. Well, this is one where we're going to have a fraction as an answer. Is 24 over 21 our answer? Well, no. You always reduce fractions as much as possible. What number could I divide both of these by? A 3? Does 3 divide into both of those? It would give us an 8 on top. And what number on the bottom? 7? So 8 over 7. So if you have the same variable, if you have the variable appearing on the same side, just combine those together. Notice what I just said. If the x's are on the same side, combine like terms. Now, what if the x's aren't on the same side? What will we do then? Let's see, here's one. 9y minus 3 equals 19 minus 2y. Y'all see how this problem differs from the one right up above it. Up above it, the variables were on the same side. Here, the variables are on opposite sides. Well, we can still combine them using the addition property. If I want to get these two y's over here with the other y, what would I need to do? Would I add 2y or subtract 2y? What will get these things to go away? Well, the opposite of subtracting 2y would be adding 2y. When I do that, let's look at what we have. You see how these two y's are gone? And over here, what do we have? An 11y, still a minus 3, equals 19. This is the most basic type of problem solving. We know how to solve something like this when there's just one variable on the left. So let's rewrite this. So now we have just one variable on the left. So how do we solve 11y minus 13 equals 19? Minus 3 equals 19? Well, opposite operation beginning with addition and subtraction. So add 3 to both sides, and we just have an 11y on the left. Notice how negative 3 plus 3 is gone. 0. 19 plus 3. What's 19 plus 3 going to be? Is that a 22? Now, we know how to solve that. What am I going to do? Subtract 11 or divide by 11? Well, divide. The opposite of multiplication. So, have we oscillated the variable? Do we have y equals a number? We sure do. 22 divided by 11 is 2. So if you have variables on both sides, just use addition and subtraction to put them all on one side. This is, again, some of those times when you'll see teachers do this. Instead of writing what I did right there, we're moving the 2y over so it becomes a positive 2y. Okay? Let's see. Here's one to do. Here's another problem. What's the next one I'm going to do? Move up some. This is example number 7 today. 5 parentheses x plus 4 equals 7 parentheses x minus 2. Another way you could read this is 5 times x plus 4 equals 7 times x minus 2. Well, we know how to handle it if there's two x's and they're on the same side. Just combine them. We know what to do if there's a variable on each side. Well, here there's parentheses. Well, have we discussed how to get rid of parentheses? Well, if I do this, what am I saying you should do to get rid of these parentheses? So remember the distributive property? So distribute the 5. That would be 5 times x plus 5 times 4 is 20 equals 7 times x. 7 times the negative 2, negative 14. Now, is this problem sort of like the one we just did? Oh yeah, there's a variable on each side. So use addition or subtraction to get the variables all on one side. Here you're going to have a choice. If I subtract 7x from each side, the 5x minus 7x, that's going to give me a negative number. There's no reason why the x can't be on the right. Remember number 2? Why don't we go ahead and put the x's on the right? What would be the advantage of doing that? Okay, if I'm going to get rid of this 5x and move it over here, I would subtract 5x. 5x minus 5x, that's gone. So we just have a 20 remaining on the right. And what do we have over here? 7x minus 5x. That's a positive 2x. Now, if we had done the other way, if we had subtracted the 7x, you see we would have had a negative. So I like doing it like this, but you sure don't have to. If you want to get the negative 2x over there, that's fine. Now that we have the x on the right, what do we do now to get rid of or to isolate it? Am I going to divide by 2 or add 14? Well, always do the addition and subtraction first. So on the left we have a 34, and on the right, what's that going to be, 2x? And now what am I going to do? Divide both sides by what? By 2 or by 34? Well, by 2. You're trying to get the x by itself. Divide both sides by 2. So we now have the x by itself on the right. And what number do we have on the left? 17? Now, I'm about to make a mistake that new teachers make. I've been doing this long enough. I shouldn't. I should know better than to do this. But I want to go ahead. This says or. Up here where I subtracted 5x, I'd said we could have just subtracted 7x. I want y'all to see this done this way, and maybe you'll understand better what I mean by saying we're getting more negatives this way. If instead of subtracting 5x and putting all the x's on the left, if I had done this, okay, make sure you understand, I'm finished with the problem. I'm just showing you how you could have done it. The 5x minus 7x, 5 plus a negative 7, that's a negative 2x, plus 20 equals negative 14. There's going to be more and more negatives. Now we subtract 20. If I want the x on the left, I would subtract 20. So I have negative 2x. The 20 minus 20 is gone. Negative 14 plus negative 20 is negative 34. Comparing, you see why I said this way is probably better because there's not so many negatives. Now divide both sides by negative 2. Negative 2 divided by negative 2 is at positive 1. And are we still getting the same answer? Oh, absolutely. Negative divided by negative is positive. 34 divided by 2, 17. It's just a matter of over here the x is on the right and over here it's on the left. Okay. You follow what I did there? Oh, so it really doesn't matter which side you get the x on. Okay? Don't spend a lot of time trying to decide. Okay? One way may have more negatives than the other, but as long as you get the right answer, it doesn't matter which way you're going about it. Here's another one. That was problem example 7. Here's example 8. Let me see. What do I want to do? 5 times x plus 4 . Oh, wait. No. I've already done that one. Here's number 8. 13 times 7x plus 1, then a minus 6 equals 1. How about make that a 4? 4 minus parentheses x plus 2. Well, this one has the parentheses in it, so we're going to need to get the parentheses, or get rid of the parentheses by isolating. Okay. By distribute the 13. 13 times 7, that would be 21 and 70. That's a 91x plus 13. Then minus 6, I'm just carrying down the minus 6, equals 4. Now be careful. To get rid of these parentheses, you're not distributing that 4. The number that's right there in front of these parentheses is just a 1. Okay? You're going to distribute a negative 1, or if you just want to say you're distributing a negative, all that's going to do is change the signs. So we have a minus x and a minus 2. Now, let's go ahead and look at each side, and let's combine the like terms. On the left, we can combine the positive 13 minus 6. So I'm going to write down 91x. 13 minus 6 is a positive 7 equals, well, what can I combine here? Well, the 4 minus 2. 4 minus 2 is 2. And we still have that green minus x. So we have the variable on both sides. Let's move all the x's together. I can either subtract 91x, or what can I do to get rid of this x and move it over there? Just add x. That's what I would do, is just add x. Now when I'm adding, realize this is a 1. Negative 1x plus 1x, that's gone. That's a 1 there. So we have a 92x, and then we still have the plus 7 equals 2. I think this one's going to be we're going to have an answer here that's a fraction, aren't we? What would I do next to get this x by itself? Well, you subtract 5 from both sides. Lost my purple pen. Okay, well, don't worry about it. Just subtract 7 from both sides. Somebody said 5. I meant 7. So 7's going to subtract out. And we have 92x on the left equals 2 minus 7. What's that going to be? 2 minus 7 is a negative 5. Now, opposite of multiplying by 92 is dividing by 92. 92 divided by 92 would just be a 1. 5 over 92. Can I reduce that? No. No number other than 1 divides into both 1. Excuse me, 5 and 92. Okay? 92 is not divisible by 5. So our answer is the fraction negative 5 over 92. Okay? So we're always start with the complicated looking equation, and you're using the stuff that we've learned. We learned how to distribute, to get rid of parentheses. We've learned how to combine like terms. Then we've learned the addition property. That's what I'm doing here and here. Adding x to both sides, subtracting 7. And then to go from here to here, we're dividing both sides by 92. That's the multiplication property. When we have some messy looking equations like this, there are two special cases that might occur. Two special cases. It's possible that you might have an equation in which every number is a solution. Okay? Every number is a solution. Then, if you have an equation that results down to where these two special cases happen when all of the variables subtract down. I'll show you what I mean by that. Like right here, if we had been going through this and all of a sudden we'd had no variables, instead of adding 91, if we had been subtracting 91x from both sides and all the variables were gone, then if you have a number equals to itself, that's called an identity, and all numbers will be solutions then. It doesn't matter. There's not going to be an x equal just one number. It's going to be x equals every number. So that's one special case. The other special case is when you get all the x's or variables subtract out, you get a number equal to a different number. It's a number other than itself. If you get something like 7 equals 7, then your answer is going to be all numbers are solutions. It's an identity. If you get something like 7 equals 0, then there's no solution. It's called a contradiction. And there's no solution. So let's do example number 9. These are the two special cases. Identity or contradiction. All numbers are solutions or no numbers are solutions. Let's see. This is going to be example 9. How about this? 4 plus 25 equals 5 parentheses 5x plus 2. Well, we know how to handle something like this. Oops, I miscopied the problem. We make the correction right here. There should be an x right there. 4 plus 25x equals 5 times 5x plus 2. The reason I put this x in red is because I'd forgotten to write it down. I want y'all to be sure to make that correction. So we'll distribute 5 here. So we have 4 plus 25x equals 25x plus, what are we about to get here? Is that a 10? Now notice how there's an x on each side. If I want to move this x over there, I would subtract it because it's a positive 25. And y'all see what's about to happen? 25x minus 25x. Do we have any x's remaining? No, we don't, do we? On the left-hand side, all we have is that blue 4 equals 10. Does 4 equal 10? Well, no. $4 is not the same thing as $10. So if you think like this, okay, we have a solution whenever 4 equals 10. Well, 4 never equals 10. So your answer would be no solution. This is a contradiction. Contradiction is what you call an equation that doesn't have any solution. Now let's look back at what I've written right here. Let me put this. If you have a number equal some different number, okay, that's what we have. 4 equals some number other than 4. It's a contradiction, no solution. We're going to do one more example, and I bet it's going to end up like this. A number equals itself. By that I mean if you had ended up with 4 equals 4, then your answer would have been, this is an identity. All numbers are solutions. This is a 10th problem. I'm going to do 10 examples today. And here's the 10th one. 3 times 5 minus a minus 23 equals 21a minus 4 times 2 plus 6a. Ooh. And this one is certainly pretty involved looking, isn't it? What are we going to do first? Well, get rid of the parentheses by distributing. I'll distribute a 3, and over here I'm going to distribute a negative 4. So we have 15 minus 3a, then a minus 23 equals 21a, a minus 8, and is that a minus 24a? Negative 4 times a positive 6 is a negative 24.